Hello everyone, good evening and welcome back to 360DigiTMG's domain analytics program. And yeah, it is the fifth day of domain analytics. We have been discussing about the transportation analytics, where exactly and how can we improve the transportation system, how can we avoid the loss, how can we improve the transportation logistics. So the very first day that we have seen what are the applications we'll be having when it comes to transportation analytics, and how where exactly we'll be using the machine learning, or it could be AI. So we have seen that on the very first day, and then we have seen first day we have seen applications. What are the machine learning applications we'll be having in transportation? And the next day, we have seen crisp ML methodologies, cross-industry standard process, machine learning, quality assurance. So what is it? In order to increase the accuracy of the particular model, of the data science model, irrespective of any domain, we'll be applying this standard phases. That is, we'll be calling it as cross-industry standard process that we have seen. And the third day, we have seen pre-processing techniques. Pre-processing. So whenever getting the data, it is in the form of raw. So how can we clean that particular data? So what are the different cleaning techniques we'll be having when it comes to structured data and when it comes to unstructured data? So what will be the difference between both? We have seen in detail, and then we have discussed what are the different machine learning algorithms we'll be having. Machine learning algorithms. What are those? Supervised and unsupervised. What are the difference between the supervised and unsupervised that we have seen, and how can we implement the unsupervised algorithm, and how can we implement the supervised algorithm hierarchy that we have seen in the data mining part. And on fourth day that we have discussed how unsupervised learning will be applied using one use case scenario. That is, we have taken k-means algorithm. We have applied k-means algorithm, and then we have saw how can we apply the one. We have taken one use case scenario. We have taken one use case scenario. In that, we have different features. Based on those features, we have segregated that particular vehicles in different groups, or you can say clusters. So these are the things that we have discussed on the very first 4 days. If you haven't watched those videos, in that case, I recommend you to go through it so that you will get an idea of how machine learning or data science will be applied when it comes to transportation. So those are the things that we have discussed in the previous classes. And today we will be discussing about unsupervised learning algorithm. Supervised learning algorithm. So what does that mean? Supervised, we have seen in the last class as well. Let me quickly go through it. What exactly the supervised? So when you have a data set, let's say this is one data set, and you will be having different features. Let's say it is x1, x2, x3. So these are all independent features. Independent features, or you can say input features. And you will be having y, that is a label column. When you have output or a label column in your data set, you can simply go with supervised. Let's take an example, COVID cases. So what are the features can be whether that particular person has cough or not. Is that particular person have a fever or not? Body pains or not? So this all can be a part of features. Based on these features, we will be deciding that whether that particular person has a COVID. If yes, if he has a COVID, in that case, we'll be saying yes. If not, we'll be giving us no. So these are the features. Based on that, we will be deciding what is the prediction, what could be the output. Based on feature, we are simply predicting what could be the output. So when you have a labeled column in your data set, when you have a labeled column in your data set, in that case, we'll be going with supervised. In that supervised, we have different algorithms, and today we'll be talking about the KNN specifically KNN, and we'll be seeing. Before getting into the KNN algorithm, we'll see what is the agenda for today's session. We'll see what exactly the nearest neighbor. In KNN, we have KNN. That is what nearest neighbor. Nearest neighbor. What does that mean? Why we are using this terminology? We'll go through it. Nearest neighbor classifier. What happens when you have just one nearest neighbor? And what happens when you have K, means you'll be keep changing that K values, that is number of nearest neighbor values. What happens in that case? How can we control the complexity of the model? Euclidean distance plays a role when it comes to KNN. That is also we will be going to discuss. So without wasting any time, let's get into the session. Yeah, first thing, what is the nearest neighbor? We'll be talking about similarity. What is the nearest neighbor? We're talking about similarity. Let's take one example. It comes under image classification. So let's say this is one image, this one more, and this one more. So how many classes we'll be having here? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 to 9 we'll be having. These are the classes. These are the different classes we will be having. Let's take, we have introduced new data into our data frame for classification, I can say. Let's say I have introduced 4 in this data set. So what happens? Whatever the image that we are giving as an input, what it will see, do we have anything similar in our training data? If we have anything similar, in that case, it will become that class. Here we have given 4. So it will simply check with other different classes we'll be having. It simply finds out the similarity. Do we have any similarity to this? If we have any similarity, in that case, it will become that class. Let's say I'm giving 7. Like that I'm giving. So it will simply check with the data frame. Wherever it is finding the similarity, it will become that class. So let's take one example how exactly this similarity works. You'll get an idea. This is for image classification, but we'll get into in classes. When you have just 2 classes, how things works out, we'll see now. Let's say pink one is a one case class. You can say class A, and blue will be having class B. Or you can give any name like COVID positive. That's a pink class, and COVID negative. That is a blue class. You can give anything like that. If you want, let me write it in blue class. B is a COVID negative. Just instead of giving like a blue class and pink class, we'll simply say that it is a COVID positive and it is a COVID negative. So for every data frame, we'll be having different features. Say this is one data frame. For each and every, let's say to decide this particular data, is COVID positive. For that, we'll be needing so many features, right? Like that I have explained previously in X, Y, Z, X1, X2, X3, and we'll be having last Y. So in that, X1 could be whether that particular person have a cough or not, body pains or not. So based on all those features, we'll be deciding whether this data point is here, and for that we'll be having all these features. For each and every data point, we will be having so many features, properties you can say. Based on those only we'll be deciding whether that particular case is positive or negative. Same case when you have blue. For that also we'll be having similar features. Based on that only we'll be deciding whether that particular case is the COVID negative or not. Normally we have one class, but for better understanding, I'm taking it. It is a COVID positive and it is a COVID negative. And here I'm taking new data. So we already have this data frame. I'm taking new data. That is what pink. When k is equal to 1, nearest neighbor is equal to 1. When you have just one nearest neighbor, you are taking just one nearest neighbor and you are giving a new data frame into, you are introducing new data point, and now you want to categorize, is it belongs to the COVID positive or COVID negative. In that case, what we'll be doing, since we are giving k is equal to 1, we'll simply calculate right after introducing that element or the data point. It will simply calculate the distance between each and every point. It will calculate the distance between each and every point. After calculating the distance, since k is equal to 1, it will simply take one data frame that is nearest one. So among all these, it will be having nearest one, this only, right? And whatever the data point that you have given, it will become that. Whatever the data point that you are given as an input, it will become that class when k is equal to 1. What happens when k is equal to 2? When k is equal to 1, it will simply, whatever the nearest or shortest distance it will be having, it will become that class, right? So when k is equal to 2, similar to that, it will find out the distance between each and every point. It will simply find a different distance between each and every data point. Each and every data point. Since k is equal to 2, it will simply consider only two shortest distance. Only two shortest distances. So here we will be having two shortest distances are this one and this one. Among those, since both are different classes, it will simply check which is the shortest distance and it will become that class. When you have two data points, two classes with similar distance, let's say this pink one is also with the similar distance. In that case, the algorithm will be in dilemma whether it should go with pink class or COVID positive, or you can say or COVID negative. So it will be in dilemma to avoid that whatever the k value that we are choosing. So it is very frequently happens the distance is similar. So whatever the k value will be having, and simply put odd always, odd. You can simply take odd value always, so that we can avoid this kind of dilemma. When you have two data, different classes, whichever the nearest one, it will simply take that and it will become one. It will become that class. If it is similar distance, in that case, so that is the reason we will be going with odd number of shortest distances. Here, when k is equal to 3, how can we avoid that when it is odd in that case? Let's say this is the new data point that you have given for the classification. Which category that belongs to. You want to figure it out that one. Whether it is COVID positive case or COVID negative case. And what we will be doing here, when k is equal to 3, so it will be calculating the distance between from here, this data point will be calculating the distance between all. Based on that distance, it will simply select the shortest 3. Here we'll be having shortest 3. Among those, which is the majority class? Among those, which is the majority class, this will become that class. So here we have blue is the majority class. So whatever the data point that you are giving, based on that its feature, it will become blue class. So this is how we can simply avoid when you have a similar distances. This is the reason we can simply give odd numbers. K value is equal to our nearest neighbor that we are taking. Better take odd numbers so that we can have, the similar distance very frequently happens. Still, to avoid that probability or the possibility, we can simply take k value is equal to odd. Yeah. So what happens? Similar to when you have taken the 8 classes, 8 nearest or shortest distances. Let's say this is the data from that I'm included. I want to categorize or classify it is into different class. So we have taken the k value is equal to 8. K is equal to 8. So it will simply consider 8 nearest values. Let's say 3. Yeah, it is already 5. Right? Among those, which is the majority? Pink. So it will become that. If it is having the majority class in that case, fine. But if it is having similarity in that case, it will simply find out which is having the least distance among those classes, which classes will be having the least distance. It will become that. To avoid that, we can simply go with k is equal to odd value. In that case, we will be having one always higher. In that case, it will become that class. Here we have pink classes are more compared to that, so it will become that class. So this is how it will simply check that value. Based on that, based on the majority, it will become that class. It will become the majority class. How can we find out which k value will be the best suitable? So when you increase, let's say this is the k value and the accuracy. When you keep increasing the k value, in that case, what we are giving, the number of shortest k value is equal to how much? Nearest neighbor. We are increasing the nearest neighbor. When you increase the nearest neighbor, training accuracy keep increasing. That is not always, but most of the time it will be keep increasing. The training accuracy it will keep increasing. And at one point, testing accuracy also increases it up to some points, and then it will keep decreasing. So here, when you have training accuracy and testing accuracy are low, in that case, this case will be called as underfitting. And when the training accuracy is high and the testing accuracy is low, this case will be called as overfitting. Or also you can call as variance. And here you can call as bias. So when both training accuracy and testing accuracy are low, in that case we'll be calling it as underfitting. When training accuracy is high and testing accuracy is low, in that case we'll be calling it as overfitting, or you can also call it as variance. So we have to find out the trade-off between training and testing accuracy. How can we find out the trade-off between training and testing accuracy? You can see where exactly the training and testing accuracy are similar, are near to similar, or exactly same. where training and testing accuracy are nearly same and it is maximum value. That value will be taken as best fit, or you can say right fit. You can simply say that is a best fit or right fit. So like that, we can find out the trade-off between the bias and variance. Like that, we'll be finding out the trade-off between bias and variance. So like that, k value is helpful to find out the best fit. It is based on the k value only. Let's take one example so that you can understand clearly. Here we have different entries. You can say cheese, celery, carrot, banana, bacon, and apple. And we have two features. What are those features? These are the features. Sweetness and crunchiness. Based on this sweetness and crunchiness, we are deciding which category that which class that belongs to. Sweetness is 10 and crunchiness is 7. Crunchiness is 9. In that case, it belongs to fruit. So it is a class. How many classes will we having here? Fruit, protein, and vegetable. We have 3 classes. So based on this feature, these 2 features, we have to decide which class it belongs to. So everything, you can, if you represent this in X and Y graph, you can see here, these are the different data points, you can say. For each and everything, we'll be having features. So let's say it is a banana in that case. You can see banana has 10 sweetness and 1 crunchiness. It won't be having any crunchiness, right? Carrot, sweetness is 7 and crunchiness is 10. So like that, each and every data point will be having here. Similar to that very first one, k value is equal to 1, k is equal to 3. We have find out, right? We'll be having something like data points. Similar to that, let's say this is our data points. This one is data point. And this one. So each and every data point has different features. 2 features will be having, right? Based on these 2 features only, we are segregating everything into 3 classes. What are those classes? Fruit, vegetable, and protein. So based on this feature, we are simply segregated everything into vegetable, protein, and fruit. So here, lettuce and celery, carrot, cucumber, green bean. So these are all comes under vegetable. Like that, we'll be having some data points in protein, some data points in the fruits. Now I want to introduce one data point, like we have seen in the very first slide. I'm simply introducing one data point. When I'm introducing some data point, in that case, it will be having its features. Based on this feature, we have to figure it out which class this data point belongs to. Let's say I'm giving tomato. So for this, we'll be having some features. I'm giving new data point, that is tomato. For that, we'll be having some features, right? Some means we have to have 2 features, like based on the crunchiness and sweetness only, we'll be segregating into different classes. So for that, for tomato also, we need to have 2 features, that is crunchiness and sweetness. And using that data point, we have to segregate this into which class it belongs to. That is the A. Let's say, yeah. To find out what is it, how can we find out the similarity? So we are talking about the distance, right? So it will be calculating distance. Let's say it is data point, and here it will be having, and it will be calculating the distance, whichever the nearest distance, it will be taking it as similarity. Based on what we'll be using Euclidean distance. We'll be using Euclidean distance. If the Euclidean distance is short or small, in that case, we can call it is having the similarity. If the Euclidean distance is more, in that case, it will belong to some other category. So that we will be using the Euclidean distance. You can simply see the Euclidean distance formula when you have to. Let's say whatever the given inputs, I'm giving 6, 4. So this is the features, like every other data point will be having. These are the feature for our tomato. So what is the feature? Sweetness is 6 and crunchiness is 4. So based on this feature, we have to categorize which class that particular the data point, the tomato that we are taking belongs to. How can we find out? How can we find out? I have already taken. Sorry for that. I've already calculated the distance, and let me show you how it will be classified into different classes. Yeah. So what do we have here? Tomato, sweetness is 6 and crunchiness is 4. And what data frame we are taking? Similar to this, these are the data frames we'll be having, right? Apple, bacon, banana, carrot. So these are the different features for this. And additional to that, we are giving tomato features. Sweetness is 6 and crunchiness is 4. When you give that data, yeah. So the same, it is a bacon, and these are the features for that particular. Now, so now what we have to find out? We have to find out the similarity between the data. To classify whatever the tomato that we are giving, which class it belongs to, for what we have to do, we have to find out the Euclidean distance. What is the Euclidean distance? 6 minus 10 whole square plus 4 minus 9 whole square. So how much it is? 4 square plus 5 square. How much it is? 16 plus 25. And it is about 41. Root 41, it will be near to 6.4. It will be near to 6.4. Like that, I have calculated the distance for each and every data. So what is the distance between, Euclidean distance between, why we are calculating the Euclidean distance? If the Euclidean distance is less, in that case, will be called the KNN, right? Where you have KNN, K nearest neighbor. If you are taking K is equal to 1, in that case, you are taking only shortest one. If K is equal to 3, in that case, we are taking the 3 shortest paths. Among those, when K is equal to 1, whichever the category, the class that belongs to, it will become whatever the data point that we are given, it will become that class only. If K is equal to 3, in that case, what happens? Whatever the classes it will be having in 3 data points. Whichever is having the majority, it will become that class only, right? That we have seen in the very second or third slide. So we are finding the Euclidean distance between each and everything. In that case, what is the distance? This is the Euclidean distance for each and every data points when you find out from the tomato, from this picture. So these are the Euclidean distance of those points. So when k is equal to 1, what we'll be doing? We'll simply selecting which is having the least distance, which is the shortest path, or which is the nearest neighbor. So for this, what is the nearest neighbor? When we can say it is the nearest neighbor, when it should be having least distance. Here what we have, 1.4 is the least distance. So when k is equal to just 1, in that case, it will become whatever the data point that we are given, it will become that class. So what is that class? It's vegetable. When k is equal to 1, our data, what is tomato that we have given, it will become vegetable class. So what happens when k is equal to 3? When k is equal to 3, we have to find out 3 shortest path, right? Shortest distance or nearest neighbors. So what are the 3 nearest neighbor will be having? So we simply looking at 3 shortest paths among all. So this is obviously 1, and then we have 3.6 as well, and then 4.2 will be having. So these are the shortest path when k is equal to 3. So among those k is equal to 3, which class these belongs to? So the shortest one, it belongs to vegetable, and the second shortest, it belongs to fruit, and third shortest, it belongs to the vegetable. Among those classes, which is having the majority? Which is having majority? What is that? Vegetable, and vegetable having the majority. So whichever having the majority, whatever the given data point will be having, it will become that class. So in this case also, it will become vegetable. In this case also, it will become vegetable. So that is the reason we'll be calling this as lazy learner. The algorithm that we are using, KNN, we'll be calling it as lazy learner or instance-based learning. Instance-based or example-based, you can say. Why we are calling it like that? So here we are not doing anything. We are simply calculating the distance. We are simply calculating the distance, that is Euclidean. Here what we are doing? We are simply calculating the Euclidean distance. Based on the Euclidean distance, whichever having the shortest path, we will be k is equal to 1. When is k is equal to 1, it will become that class only. We are not doing anything special. We are not applying any intelligence here. Simply based on the distance only, we are saying that which class that particular belongs to. Instant based means we'll be having different instance. This is one instance, Based on the instance, using that reference, we'll be classifying into different classes. Example based, these are the example instances, examples. Based on these examples, we are simply saying that it belongs to this category. So here it is a majority. So in that case, it will become, in both cases, it will become vegetable class. Here we have 3 classes. When k is equal to 1, it is become vegetable. When k is equal to 3, in that case also, it will become vegetable. Like that, the k nearest neighbor algorithm will do the classification. Here we'll be finding out similarity using what? Euclidean distance. Using the Euclidean distance, we are simply finding out the similarity between these. So how we get an idea about that? And now we will be having one use case scenario. In that use case, we'll see how can we apply the machine learning when it comes to transportation analysis. So this is the data frame we'll be having. It is public data set only. If you want, you can simply go through Kaggle and you can pull the data up. You can easily get the data. So it is a public data set only. So what I'm doing here, we'll be having different information, different features. Before getting into that, let me go through the objective of these particular algorithm that we are using. So we have different features. Based on the feature, we have to classify which class that particular vehicle belongs to. Which particular class that vehicle belongs to. So what are the features we'll be having? Here you can see. Yeah, before that, import pandas. Since why we are using the import pandas? If you want to do any manipulations or manipulation in the sense, if you want to change anything and any changes, or if you want to modify something, modify pretty much same. And if you want to remove any null values, all the modification changes regarding the data frame, it will be present in pandas. And then we'll be having NumPy. What is NumPy? If you want to do some mathematical operations, in that case, all those operations will be present with NumPy. And here I'm importing the data set. So I'm creating one memory pointer, that is df. In that, using the pandas to read the file as well, we will be using the pandas to read, importing pandas as PD. Here I'm using short form. I'm importing pandas in the form of PD. Why I'm using that? So that I don't need to use pandas again and again here. PD. I'm simply using the short form, that is PD. df. I'm creating one memory instant, or you can say variable. I'm simply saving that whatever the information that I'm importing into the data from df. And I'm using, since it is a CSV file, I'm using read_CSV. So by default, we'll be having this separation. So let me run it. Yeah. So now file has been imported. The data set is also imported. If you want to check what are the features I'll be having in that particular file, in that case, you can simply click on the data df.head. In that case, by default, I mean, when you use df.head, it will, by default, it will show you the first five entries of your data frame. So in that, you can see these are the different features we'll be having: HP, horsepower, and CCM, weight, torque, acceleration, height, width, length, vehicle class. This is you can see, right? This I am using as a target variable, and brand code and vehicle code, maximum speed, fuel type. So these are the different features I'll be having. Based on this feature, I have to categorize which, I mean, what features are belongs to vehicle class, which feature belongs to which class. Similar to this, how can we compare whatever the example that we have taken when you are going through the theory? There we have just two features. What are those? Sweetness and crunchiness. There we have just two features, sweetness and crunchiness. Based on that, we have to classify whether it belongs to fruit or protein or vegetable. Here, how many features we'll be having? 1, 2, 3, 7, 8, 9, 10, 11, 12 features we'll be having. So based on these features, we have to figure it out which class that particular, which class these features are belong to. In that features, we have some features that are unnecessary, not useful to predict which class it belongs to. So in that case, what we can do, we can simply remove it. And you have so many, if you have any duplicates values, in that case, what you have to do, I will do a little bit of pre-processing that is necessary. So I'm simply dropping. If I have any duplicates in my data, in that case, what happen? It will simply drop everything. And how many data frames? I mean, length of the data frame is 5,999. This is the length of the data frame. How many entries will be having that? It will simply show you. And info, play the info. What happens when you do info? In that case, it will show you all the columns and which data type those columns are holding. So these are the different columns we'll be having, and these are the data types it is holding. So here I'm simply checking how many unique values will be having. Fuel type, how many we have. So here, do we have any unique values? Maximum speed and fuel type. It is simply, you can simply check fuel type. All our null values will be having. Maximum speed also will be having 0. So these are the null values. When you have null values, see, what is it? Here, when you find out the unique values, it will simply show you how many unique values will be having in that particular data frame. So if all are 0, in that case, whole data frame is 0, 0, 0. And null means all the data frame is null. In that case, we don't have any data present in that particular features. In that case, do we need those features? I'm simply dropping those features. Let's say these are the fuel type, maximum speed, fuel type, and then maximum speeds. These are the feature I'm simply dropping. Info, run it, and fuel type, maximum speed, and brand code. Since brand code doesn't represent which class that particular feature belongs to, it is simply brand number, and that also I'm dropping. And here vehicle code also doesn't give you any information. It might be giving you what exactly the code of that particular vehicle, but to decide which class that particular vehicle belongs, for that it is not giving any information. In that case, I'm simply dropping that. Drop function I'm using to drop all those. After dropping all those, now you can see what are the features we'll be having. So you can simply same length we'll be having same. And when it comes to features, we have removed fuel type. Since we have, it might be if we have value in that fuel type, it might be help. But here we have just null values. So all are null values. In that case, we have removed maximum speed, brand code. Yeah, it might be useful if we have information in that, but we don't have any information in that. That is the reason we are simply dropping it. Here we have the new features. I mean, right after removing those features, these are the features we are considering to find out whether which class those vehicles are belongs to. These are the classes we'll be having. Different classes we'll be having. And now I'm simply taking class as a byte. I'm simply splitting into dependent and independent. So X is an independent variables, and here Y is a dependent variable. Dependent variables means you can say labeled column. So I'm simply dropping. I'm simply splitting into Y is equal to vehicle class. Run it. And X is equal to, other than vehicle class, all I'm taking into the X. Now, since the data frame is okay, I've finalized the data frame. Now what I'm doing, I'm simply splitting the data into train and test. So here I'm how much data I'm giving for train, how much data I'm giving for test. You can say test I'm giving 0.2. In that case, the train automatically will take 80% of the data. For test, I'm giving 20% of data, and for train, I'm giving 80. Now run it. Yeah, now I'm importing the k nearest neighbor. Since everything is done, if you so this is very base model. If you want to improve, in that case, you can go to what are the pre-processing technique we'll be having, whether we have any duplicates value that we have checked, null values we have checked, and if you have any outliers in our data or not, you can simply go with box plot and you can check for the outliers as well. Do we have any correlation between the data? In that case, you can do it. And if you want to do some feature engineering on that particular data, making making use of the existing feature, if you want to make new feature, in that case also you can do it. Those are the different things you can do it, but we are here building just a base model, the transportation analysis we are working on, right? So here, based on the vehicle features, which feature that belongs to. If you know that, in that case, at what time and at which place we have to use that particular vehicle, you will be getting one idea, right? So what I'm doing here, I'm importing the k nearest neighbor algorithm or model, you can say, from sklearn neighbors, import the k nearest neighbor. This is the algorithm that I'm working. So I'm simply importing it and I'm fitting that model. I'm simply fitting that model. Importing that model and simply fitting. I'm simply fit. Fitting means we are doing the model training. Train data I'm simply using to train that particular model. And how many nearest neighbor I'm taking? Unique. 11 k value is how much here? K is equal to 11. I'm taking k is equal to 11. So 11 nearest neighbors I'm considering. So is it the perfect one? No, we can do multiple iterations. For that, you can simply use one loop, for loop from 1 to 50 values. You can check wherever k value is giving highest. In that case, you can consider that only the best one. So if we have k test value is equal to 20%, in that case, how much accuracy it is giving? I've already imported, I'm already fitted, I've trained the model. Now I want to check using the test. So how much I'm getting when test size is equal to, in that case, it is giving 78% accuracy. And if I am using the similar to that, I'm using 30% as a test size. In that case, it is giving 77% only. So if you are increasing the test size, it is keep decreasing. So from this, what you can do, what are the conclusions that you can make? Maybe the number of classes that we are taking, maybe that is not enough, or maybe we don't have enough information to do the prediction. These kind of information that we can go with. And it is a not best model, but if you want, you can add some more information so that you can get precise result. The 78% and 76% is not that great accuracy, but if you want, you can simply improve this model. So, but this is how you will be applying the KNN algorithm when it comes to data frame. So this is how you can apply the KNN algorithm when it comes to. First, we simply import the data, and if you have any anomalies in your data, you can do simply pre-processing. Once pre-processing is done, you have to import that particular model from where sklearn we are importing, and we are training the data using train. And you can do a lot of other things as well. Since it is a classification, we have to check whatever the classes, multi-class, right? This is. So we have to check whatever the classes will be having balance or not. So when it comes to multi-class classification, we don't have any thumb rule. Based on the common sense only, we have to select whether it is balanced or not. If it is not, we can use smooth technique. If it is not balanced, in that case, you can synthetic minority or sampling technique you can use, and you can convert the unbalanced data to balanced data, and you can simply apply. So this is how you can apply the KNN algorithm when it comes to real-time cases. Yeah. Like that, we can simply categorize into which particular category, which class that our data set is, or which class that particular call belongs to based on what given features. So yeah, that is it for today, guys. I hope you guys learned something. I hope you guys learned something. And if you want to kickstart your data science career, in that case, you can simply go to YouTube and you can search Tame Python by Bharani. You will be getting 22 days of Tame Python sessions. So please go through those Python session. It is necessary to start a data science careers because everything we'll be doing using the Python only. So if you want, you can simply go and learn those Python sessions. And if you want to learn transportation analytics, how machine learning algorithm is applied when it comes to transportation, you can simply go through the previous 4 videos. And if you want to continue in that case, you can we'll be having in next class we'll be having decision tree algorithm, and in that decision tree algorithm we'll be taking one use case scenario and we'll try to apply the decision tree algorithm on that, and how decision tree algorithm will be working, that we will go through. And then we'll be having linear regression and all those things will be coming up. So if you want to if you are interested, in that case you can join upcoming session as well. And yeah, guys, that is it for today. I hope you have learned something, and thank you for joining with us. And we'll see you in the next class with one more algorithm and one more use case. And until then, have a nice day, guys, and we'll see you soon.